the capacitor ESR meter. In the 1980s, I was using this capacitor meter to check if a capacitor was still good. I was unaware of ESR. ESR is equivalent series resistance. Every capacitor is a complex model, and internally there's a resistance in series with the capacitor. If this resistance increases, it reduces the efficiency of the capacitor, especially in switch mode power supplies where they're exposed to fast impulses and high heat. They can deteriorate and the ESR goes up and you get more ripple on the power supply. So mid-1990s, well, this design is based on Bob Parker's design. Bob Parker, an engineer from Australia, mid-90s he designed an ESR meter. It was published in Electronics Australia. It was picked up by a chain of electronic stores. They made a kit out of it. And back then I bought this. Very useful, but I don't like things with batteries, you know. And this thing went viral on the internet. Everybody who has to do something with repairs of power supplies should have it. So that's why I bought it. A very useful thing. And this is my version of it. It's based on Bob's version, but I replaced the CPU with an ESP32. So functionality is similar. Let's have a look. So in Bob's design, you have the short eclipse and then reset a 0 value. Now, in this version, this calibration is saved. So you only need to do this once, unless you replace the leads. I have a capacitor here. Well, let me just take one, which is a good one. This is a very low value. This is a 1000 microfarad 10 volt capacitor. Now you can see here the tables are printed on the device. I have the tables in here, so I can just scroll there. And I can see 1000 microfarad 10 volt should be 0.12 ohms. So this is a good capacitor. I'll take another one. This measures 14 ohms. It's a 1500 microfarad 10 volts. So it should be between 0.12 and 0.09. So this is a real bad capacitor. So there are three ranges. It's fully auto ranging. And yeah, it measures the ESR. I have a menu here. I can put it back to sleep, or I can reset the calibration values. And that's about it. Let's have a look at the ESR module. In the front, display, rotary encoder, connection to the capacitor, ESP32, power supply. The measuring part is powered by 5 volt. So we have a level shifter, 3.3 to 5 volt. We have a small EEPROM in the back to store the calibration. The design is based on the design from Bob Parker from the 1990s. It's published in Electronics Australia and also in Silicon Chip. 3 current sources, a discharge, measuring amplifier, a ramp generator. This Zilog is obsolete by now. It has an internal comparator that it uses together with the ramp, so we can't use that. We use an external comparator, as this one. So it will shoot a small pulse with a controlled current to the capacitor via bipolar capacitor. The capacitor, since the pulse is very short, it will not have enough time to charge. So the current will flow because it will try to charge itself. So it will basically be a short. So the ESR is equivalent series resistor, is a resistor in series with the capacitor. Now the capacitor is shorted, so what we are actually measuring is the resistance. So the voltage over the capacitor will be the voltage over the resistor. So we know the current, we know the voltage. Measurement is done by comparing it to a ramp, which is also controlled by a current source. So we have a nice linear ramp. And when the comparator is triggered, we can then calculate the actual resistance. So that's all there is to it. The design is widely published and widely documented. So the code has been written from scratch on the ESP32 based on that information.